Hey there, this is Mr. Kern and the seminar. Anyway, this is part 2 of the how to do the worksheet video. Jenkins just snorted. I bet you heard that. Part 2 of how to do the worksheet video. Basically, the first one was the first page. This is the second page. So if this is all you're looking at and you want to know how to do the first page, look at the other video of how to do this. All right. So looking on here, how many liters? How many liters can we make with 6 moles of sugar? So if the question is how many liters, we're going to end up being down there. They give us molarity, they give us 6 moles, so we're doing this step. So we take the 6 moles, we're dividing it by the molarity, which is 0.75 moles per 1 liter. And so 6 divided by 0.75 gets us, one moment. Alright, that's going to get us 8 liters. So that one's the simpler version, just one step. To know volume, you need molarity, moles, divide them. Alright, next up, how many milliliters, which again is volume, can we make if we have that molarity? You'll see molarity is just a connector. Like, this is the only place molarity shows up is in that step. And with that mass. So we start here, we're doing one step, another step to get to molarity. When we get done, we have to remember to turn it into milliliters. So first off, we take the mass, 140 divided by the molar mass. So the molar mass of NaOH, Na is 23, OH is 17, so altogether that's 40. So 140 grams divided by 40 grams per mole, that'll tell us how many moles. So that ends up being, let me find this stuff better. Alright, that ends up being 3.5 moles. Okay, so we're right here, 3.5 moles. Okay, so then to figure out the volume, we need to take molarity, or the moles, the 3.5, divided by the molarity. Our molarity is a 3 molar solution. So if I just have a pile of 140 grams, how much of this can I make? It's whatever 3.5 divided by 3 is, which is 1.16 liters. Sig fig for that, we need to have 2. And so that would be 1.2 liters. They want it in milliliters, so we move the decimal 3 to the right. We're taking it times 1,000 is 1,200 milliliters. Knowing that, why do we take it times 1,000? If I know how many liters, I'm taking it times 1,000 milliliters in 1 liter. So there we go with that. Alright, next up, we're looking at diluting. So we want to know what's the new concentration if you dilute 50 milliliters of 2.5 molar and you turn it into 200 milliliters. So first off, if you see the word dilute, you know you're kind of not necessarily working on this the same way. If you're diluting something, the equation is that you have an original solution and a new solution. So old, new. So anytime you change the concentration on things, this is, well, sometimes this is what you're going to be doing, is taking the original solution, making a new one. And you have to put things in the right place. So they want to know what's the new concentration. The new concentration is this guy. So you want to end up calculating M2. That must mean you know the other 3. So you plug in the numbers. The original solution is, with that word of, you take that original solution of 50 milliliters of 2.5 molar. And you're going to change that into a new concentration of 200 milliliters. Now, the way to do some of these things a lot easier is we changed the volume from 50 to 200. So how many times bigger is the volume? So that would be 50 times 4 equals the new volume. So volume went up by 4. Volume and molarity always do the opposite thing. And so that must mean the molarity went down by 4. So I'm going to guess what I'm going to end up doing is taking that divided by 4 to get my answer. Alright, so to calculate M2, we want to get it alone, so you divide by 200, divide by 200, and so what you end up is 2.5 times 50 divided by 200 equals 0.625. The unit was, we want to figure out molarity, so 0.625 molar. Now, sig figs need to be 2, so that should be a 0.63 molar. So, if I were going to compare my prediction, I thought 2.5 divided by 4 equals that, yeah. So if you think about prediction, whatever the volume does, the molarity does opposite. So if you can figure that out, you might not need to do all of that math to be able to get it. Alright, so for the next one, you want to make that. That's solution 2. So that's 0.05 times 500 milliliters. You would need how many milliliters? So you're calculating B1. So just as you read, plug the numbers in to the right spot, what you made and what you started off with. You have a 1 molar solution that you're using for that. So to get V1 alone, you take a 1 molar solution, get rid of it, divide by 1 molar. So it ends up being 0.05 times 500 milliliters. Divide by 1. So 0.05 times 500 is going to be 25. That's the volume. That's in milliliters, which is not what your answer key says on the back of that. So good thing you watched this. Alright, so what that means is if I take, or I guess if I were going to write the instructions for how to make this, I would say step 1, measure out 25 milliliters of, I'm just going to say it again, right? Step 1, measure out 25 milliliters of your 1 molar solution. Step 2, add water until it hits 500 milliliters. So that's how I can make 500 of that solution. Alright, so for this last one I'm going over on the worksheet, it's a lethal dose one. How many liters, so automatically how many liters tells me I'm going to end up on this one down there. How many liters of 4 molar NaOH would a 4-pound rat need to drink to reach the lethal dose? The idea of lethal dose is every kilogram will make it need to eat 3 grams. So already in your head, you just figured out it's going to take 12 grams. So how do you figure that out, other than just that you're a genius? Oh wait, sorry, that would be 4 pound. So it wouldn't be 12 grams. Darn it. So
Brent Smith, please report to the office.
We need to turn pounds into kilograms. We need to use kilograms of your body weight to get how many grams. Let's see. So once we have grams, we need to end up being on liters. So how do we get to liters? I need to know the moles and the molarity. So I'm going to turn grams into moles and then divide that by the molarity to equal liters. Okay. So the basic idea on the lethal dose stuff, you always have to make sure you're in kilograms, not pounds. You're going to end up at some point calculating how much it's going to take to kill you or a rat. And that's by taking the body, the weight of it, in kilograms times the lethal dose. Okay, you did that earlier on the worksheet. Now it's the point of, once you have grams, what can you do with grams? If you're here, you know grams, the only thing you can do is turn it into moles, and then in this step they're taking another, or in this question they're taking another step. Okay, so let's do some math. So we know I have 4 pounds. I'm going to get rid of pounds, turn it into kilograms. So I know it's 0.45 kilograms, that's a 5, in 1 pound. So I just got rid of pounds. I'm going to turn kilograms of body weight into grams of poison. So 1 kilogram of body weight means I need to eat 3 grams of poison. So I got rid of kilograms. Yay me. So I want to turn grams into moles. So I take grams divided by the molar mass. So molar mass is, for sodium hydroxide, figured that earlier, molar mass of that is 40. So 40 grams are what's in 1 mole if I ate 1 mole. Or if my dog ate 1 mole.
Mr. Crowder, you have a phone
So
call
we can
line
hit
two.
equals there, and we can get our answer for how many moles we ate. Why do we care about moles? The question asked about the volume. How do we get to volume? We need to know the moles divided by the molarity. It really boils down to every question. There are 2 things usually that you have to end up getting. If the question doesn't give you those outright, saying, hey, I ate this many moles, then you have to figure out what's the path to get there. So if you go along the way, if you hit equals here, you'd say that would be 1.8, 1.82. Then you sig fig down to really just 1. So that would be 1.8 kilograms or 2 kilograms. When I worked this, I didn't hit equals there, so I worked the whole way through not with 2 kilograms, but with 1.8. So if you hit equals there, you have to really change it into 2. You do sig figs at the end. I'm going to keep working it like I did earlier, just so my numbers work out with 1.8. Alright, 1.8 kilograms. Every kilogram had to eat 3 grams. So every kilogram of body weight had to ingest 3 grams, so it's 1.8 times 3. So that would be 5.4 grams it would take to kill the rat. So if the rat eats 5.4 grams, it has a 50-50 shot of living or dying. So now I'm here. I have 5.4 grams. So what do I do with 5.4 grams? I take it divided by the molar mass, and so that would tell me I've got 0.13 0.135, which we round that to sig figs, we'd say 0.14 moles of NaOH that ate. So this is 0.14. 0.14 divided by the molarity is what it's going to be to kill the rat. So how many liters of this stuff? 0.14 moles divided by 4 molar equals 0.034. Now we had to sig fig that. It's 1 sig fig, so it's 0.03 liters. So that would be 30 milliliters is what the rat would have to drink. Okay. So again, pounds automatically turn to kilograms. Kilograms times this, the lethal dose, will get you grams, and then do what you can do with grams, which is turn it into moles and then answer the question. On number 2, whoa, that was weird. All right, on number 2, just to help you out, I'm not going to work it out, but on number 2, they give you a situation of like you come home, you find what your dog drank, then you have the question, will my dog live or die? So really, it's 2 questions. Number 1, kind of like this, um, how much? That's an H. How much will it take to kill your dog? Which hopefully didn't happen. And then, how much did the dog
Mr. Diller,
drink?
give a phone call line 2.
If you know those 2 things, then you're able to compare. So how much will it take to kill the dog? 70 grams. How much did the dog drink? 80 grams. Sorry, dog. Or the other way around. So again, that's not the answer, but those are the 2 questions that you're looking at to be able to answer this. Okay.